Hello, everyone, and welcome to the IriusRisk webinar, AI Prompt Engineering for Secure Architecture. So I'm Fraser Scott, VP of Product at IriusRisk, and today I am joined by a fantastic panel of experts to discuss the role AI prompt engineering has in secure software architecture. Our first panelist is Adam Shostack, a renowned threat modeling expert, author as well as consultant. We're also joined by Kelley, who is the CISO for Protect AI, is also an author of a number of books on secure architecture and cryptography. And finally, we're joined by Jose Lopez, who is the head of AI at IriusRisk and has an extensive background in machine learning, natural language processing, and large language models. So welcome to everyone. Welcome to our panelists. Before we get started, a bit of housekeeping. If you have questions, please use the QA functionality in the webinar. We'll cover those questions either throughout the discussion or at the end. The webinar itself will last about 30 to 40 minutes. And then, of course, we'll be making the recording of it available in the next few days. So to kick off the discussion, it'd probably be useful to set the scene. I'm not going to assume everyone knows what prompt engineering really is. So what is prompt engineering and what does that have to do with cybersecurity? Diana, let's start with you.
Prompt engineering is putting prompts into the model, either in order to get an output from it, or it can also be part of your training. So you can train the model as the prompt. But essentially, if you're using an LLM or a chatbot, think that the prompt is what you're entering into the command line interface in order for it to give you a response.
And so what role do we hope or think that this plays in building secure architecture then?
Well, there's the part that's about training the model itself. So making sure that the model is going to be able to be custom fit or trained properly in order to give the responses that would be helpful. For example, if it's going to be a specific use case for reporting out or for architects to use, you'd want to do the prompt engineering to train it to behave or to respond accurately. And then importantly, how the engineers that are interacting or the analysts that are interacting with the system, what they're doing to ask. So it'd be questions that they could ask that would help them with security architecture. It could be anything from asking them about threat modeling. Could you help me do a threat model? Or I've done a threat model. Can you review this? The prompt could be, here's the threat model I've completed. Could you review it? And did I miss anything? Are there aspects that or questions that weren't asked? That would be one way that it could be used.
Very good. Adam, in your experience, what have been the benefits of using this as opposed to sort of tackling it the more traditional route? Then, are we seeing success with prompt engineering for secure architecture?
So let me build on what Diana said and say that I think a piece of prompt engineering, which is absolutely crucial, is not just using the model and putting in a prompt, but varying the prompts and seeing what happens as you do so. And because that, to me, that's the engineering part of the engineering. And a lot of people use prompt engineering, and I'm going to be a little bit rude, they're just sort of dinking around rather than engineering. And one of the fun things about these models is they're so powerful that often just works. And it can be, it can fool us, right? We're used to things that we're used to only humans talking like humans. And the fact that these things talk like humans triggers this anthropomorphism in our brain. And so when I think about this, I've been spending a lot of time doing evaluations in a couple of different ways. One is I will throw the same prompt repeatedly into the same engine and look at how it varies the output. Then I'll make little changes to it and say, is it sensitive to words? Yes, they're all really sensitive to the words you use. Then you can start to say, okay, if I evolve my prompt, does it get smarter at answering my question? If I go from engine to engine, does it get better? And the questions Diana asked are great questions. And it turns out you can get really useful answers. And the first thing I think about is just blank page syndrome, right? It's easier to edit than it is to write. It's the internet functions on this. It's easier to be judgmental than it is to be useful. And so if the thing gives me an answer, I can judge the answer. Even if I'm not really good at doing the work, I can say, that looks wrong. This looks interesting. So those things are things that I think are incredibly valuable.
So that's interesting. So one of the downsides of getting off of the blank sheet of paper where it has been generated by a large language model is sometimes the same kind of problem you see in workshops when you're doing like product or brainstorming workshops. You're starting from a certain point of bias. So yes, you're editing, but you're editing from a starting point that the LLM decided for you, and it's very hard to break out of that sort of myopic view. So Jose, if we go over to you then, what are your thoughts on some of the challenges with bias in this sort of problem of prompt engineering, into either what that you provide or what comes back out of the LLM?
Yeah, well, I think that the best way to try to avoid that bias is repeating the exercise that Adam has said. Is you can try exactly the same prompt more than once, and then the large language model is probably to give you different answers for the same thing. And that's a really good exercise for the very beginning. It's like when you are starting something, you don't really know what is the direction. You can try the same prompt and different questions. And the average is like, yeah, that, around that place is the right answer. I will start doing something like that. I always do it, by the way.
I obviously do something like prompt engineering, maybe not quite so engineering-y as Adam said. I probably fall into the lazy bucket at the beginning of just like hoping for the best. One thing I do personally do is often to try and get around that, I ask for like, give me 10 of something, and I hope that it's going to like have some variation in that. Mm-hmm. I'll open this up for whoever wants to respond. Is that a viable approach, or does that just bring in a different set of biases?
No, well, sorry, Jose.
Sorry, go on, please. Go on.
Yeah, I was just going to say with the bias, I mean, one thing that can help there on the human side is to not just be going at this alone. So how do we eliminate bias in real life? We can do that as we're doing the prompts too, is to have a brainstorm. So you can have a brainstorm prompt session, and different people are going to think of different prompts. So that can actually help quite a lot. I do think if you just ask for 10 different variations, sometimes what you do is you get the same mistake again and again. I was doing something I was testing with ingredients, and I ultimately found out that it was when I was saying, create something out of this list, it was replicating what an ingredient list would do. So if I put something first, it assumed that had to be the most in it, and it just kept doing it and doing it. The only thing that 10 gave me was eventually I saw the pattern of the mistake that it was making, or not the mistake, but it was repeating a pattern that I didn't want it to make and hadn't expected to make. So yeah, I think that asking for 10 may help. It may get you to see that there's a bias, but it's probably not going to give you the same difference that you would get either from using multiple models by asking the same prompt to multiple models, or most important, getting different viewpoints on what this prompt should be, and different people saying, hey, wait, I think I see something.
Yeah, I agree. I think there is something that is interesting in large language model to understand when you are using the large language model is how it works. So a large language model is using the words that you have, in your prompt plus your context, which is, the whole thing that is inside the conversation, to calculate the next token, the next word, the next character, or whatever. In this case, it's token, but yeah. And so for that token, every single token that is in the context is affecting to that token. So it's repeating the same structure, not exactly always, but sometimes it's repeating the same structure. So you can avoid that thing, like if started the whole thing again with exactly the same prompt, because the bias is going to be different every single time. There is something that is called temperature, which is, like a random seed, something like that. So something like that. But what we can think about that that concept. But at the same, at the end of the day, you are going to have different things for the same prompt. I think that's a good approach for the beginning. Although I usually use the 10 things as well. I mean, you can use both things. You can use both things.
So I think this. Sorry, Fraser. I think this brings up a really interesting, again, an engineering challenge, which is, let's say you're having 5 or 6 people do similar prompts, but the temperature is changing. What are your records like? How do you determine if you've done a good job? Do you capture all of the LLM output as meeting notes? Do you capture the ones you think are good? How do you make sure that when you've got 3 security experts, you're getting 3 similar answers? Because there's nothing, I mean, people are a little tolerant these days of LLMs being inconsistent. But one of the big problems that we see with threat modeling is the ask 2 experts get 3 answers problem. And that really frustrates the people around us. So LLMs sort of magnify that, and I don't know what to do about that yet.
Interesting.
I don't think that's a bad thing. I mean, you are going to have 3 different approaches, which at the end of the day, I mean, the human is in the loop. So you are the one deciding. So it's not repeating the same thing once and again. It's more like helping you to do your job better. So you can choose what is going to be the best, or the best first approach, and then you can fine tune that approach. I think that's possibly, I mean, because at the end of the day, it's the human who is leading the thing.
Another important question or consideration is that the context and the amount of information that you can give to the prompt is going to directly impact the utility of the output from that model. And when we're talking about whether it's software security architecture or network security architecture, in order to get beyond just general, does this make sense? Is this, you'd want to have very specific information about your environment or about your piece of software, about your solution that you're trying to build. And that's going to start to bring up some questions about, do we feel comfortable giving all that data to the system, even if it's a private LLM? Is it then tuned going to give you the information? So I think that's another one, is especially as we're using these big public LLMs, because we're talking about the public ones. Are you going to be able to get a useful architectural response, guidance response from that LLM based on what you feel comfortable giving them?
Even before we get there, there's the question of, can I give the LLM this data?
Oh, yeah.
Right, there's... Gemini Google just announced that Gemini has a 1 million token context available to it. But one of the things that, and Claude used to be the champion with like 200K tokens. But one of the things we see is that these large context models tend to lose track of a lot of the context as they respond, and they have what's called a recency bias, where the last bits of the thing you put in might even be the only thing that counts. And so, as we think about prompt engineering, and as we watch how quickly these tools are changing, and I don't want to discount the point of, should we tell the model all of these things?
Can we? Yeah.
Can we, and how do we get to the point where we really understand what the strengths and weaknesses of the tool are as we're doing this?
I think that's key, and I think that every single model is different. GPT-4. Oh, sorry, my headphones again.
You hear me now?
Yeah, I can hear you.
So every single model is different. GPT-4, I mean, there is a really interesting test. It's a benchmark, which is called the needle in the haystack, which is you have a prompt, which is a really big prompt, and then which is related with something, a matter, and then you insert something that is completely unrelated to that matter in the whole context. And then you ask the model about that specific thing. If the model is responding you, then, I mean, and you have that specific thing in the beginning or in the middle or in the end, you can calculate where is the place where some specific things have, more attention or less attention. GPT-4 is really good at that thing. It's like the whole context. It can, focus the attention to every single place. Claude is really good as well. But as a prompt engineer, you need to know specifically those things for every single model when you are working with, because otherwise you are going to probably lose that, something that is important for you if it is in a place in your context, as for example, in the beginning, or as Adam said in the last part, usually the place where the model focuses all the attention. I think when prompt engineering is working on something specific, you need to know where are the flaws. Claude 3, for example, is working better with XML, but GPT-4 is better with JSON. So you need to know all these things, because when you are prompting, you need to understand how your large language model is working.
Yeah, just before we move on, my understanding is there's different types of, let's say, interaction models when it comes to prompt engineering, and we talked about giving the context up front. Are there other alternatives that people can explore to having, because it's not necessarily just like giving a prompt and getting an answer, right? It's often a sequence. So are there other ways of structuring the sequence of engaging with large language model? Are there ones that tend to work better than others? I just wanted to sort of double click on that a little bit.
I can answer. I think that, that's really interesting, because there is something that is called prompt chaining. You can have a really big prompt, which is confusing the model, because there are a lot of things, a lot of commands, orders, and in the middle. It's like, and that's a really interesting thing. I can tell you, don't think in an elephant. You are thinking in an elephant. So the trick is not to tell you to not think in an elephant. So one thing that you can do is to prompt one thing, wait for the answer, and then prompt another thing. Because the second prompt can confuse. If you are giving a really big prompt instead of chaining the prompts, can confuse the first one. That's another thing that you need to take into consideration. Yeah.
Yeah, which I do think, like, a lot of people, we sort of think of the LLM as just this like big monolith, but there can be chains. If, for example, you're good, like if you're doing lang chain and math chain, then you say, what's the square root of 49? But then math chain is converting that into Python. And then that's what the LLM is acting on. So it is a good point about the chaining, and also understanding how that's going to, what your prompt, how that may transform throughout the process. And the best way to understand what you're doing with what's happening is continue to look at the output. That's what the engineering part, a big part of the engineering part, is that trial and error, is to continue to say, let me improve this. Oh, I asked this, it got close. Let me get a little bit better with it next time. That's a big
100%. Yeah, I agree.
So if we bring this back to cybersecurity and, let's say, threat modeling, then what are the implications here for threat modeling? I mean, threat modeling as a cybersecurity practice brings with it its own set of challenges, right? You're having to deal with something that doesn't necessarily exist yet, so you're working with design artifacts. So what does the sort of the blue sky look like for this approach to prompt engineering, and what it can do for threat modeling? Adam, over to you first.
Sure. So I think there's a set of tasks that we can think about asking an LLM for help with. We can say, I'm thinking about building something that achieves business case X. What are 3 or 4 different ways of architecting it? And then if we change from that, what are the security implications of those decisions? What are the important decisions I'm making early on so that I can be aware of their implications? Because a lot of threat modeling, right, the back of the napkin whiteboard style of threat modeling is about we could do A or B. And getting those A, B, C and comparing them can be huge. I think another place that makes a lot of sense is saying, I'm building X, what should I watch out for? So we've narrowed down our choices, we're getting more specific. And then one of the things that LLMs can do is information retrieval, right? It's searching a massive context and say, here's the thing that's responsive to your prompt. And having that naive, overconfident, not very reflective security engineer in the room with you, with the LLM, lets you iterate faster. And I think there's an awful lot of the challenge that we face in how do we scale threat modeling is how do we get people the skills? How do we get this to happen early? My colleague Jamie Dickin just gave a talk at RSA on teaching every engineer at New Relic how to threat model. And they had the same problem everybody else has, which is they don't have enough security expertise. So the threat models happened as a gate late in their process and were way less effective. And it's a great talk. She talked about how to get every engineer to do a little bit of threat modeling and how much success they're having, but we can even enhance that with LLMs. And I think that's an incredibly important thing to be exploring.
I think Adam sort of alluded to this earlier, but I think a really important thing for folks looking at using LLMs as part of their threat model activity is to think of it a little bit like we used to think about Nmap way back in the beginning of penetration testing getting picked up, which is that it's a good start, especially if you tune it right, you ask it the right questions, it's going to get those ideas flowing. But this is by no means, we are not at a state, I don't know if we're ever going to get there, but we are absolutely not there now, where you can do a complete threat model just with an LLM. What it really is more is kind of like that getting started point, that Nmap equivalence. Yeah.
So there's a couple of questions come in, which we'll address in a second, but I think they'll take us in a slightly different direction. So just to finish this bit off, where does prompt engineering sit? So if I'm a developer and I'm doing threat modeling for the first time, I can use, and let's say I don't have access to a security expert, I can use an LLM to get me part of the way. Now, I can go to a security expert who has the knowledge, has the critical thinking, and give them my context, and then they'll be able to sort of guide the threat modeling process. Whereas if I go to an LLM, I guess the question I have is, on the spectrum of telling somebody what to do versus telling someone how to think, where does the sort of prompt engineering of an LLM sit in there? Because I get the impression that sometimes you're almost having to structure the thought process of the large language model for you based on like the interaction model, as opposed to this sort of, here's my use case, let me lean on your expertise. So just any thoughts on that from anyone?
Yeah, I think that's the process of prompt engineering. That's what really you need to do, is like how I can express my needs in a way that this tool is giving me, the right answer. It's not like a magic thing. Here you have. It's not an expert in that way. But I think that with the time, I mean, right now it's very early. I mean, if we think about large language model, it's really, really early. I think that it's going to be mature in time, and probably we are going to reach a point where this is going to be more natural for a person to say, you are my expert, here you have. But meanwhile, we reach that point, we will need to put in our heads how to structure the message. Yes, go on, please.
Sorry, thank you. I was going to say, I think that as the LLMs continue to mature, how we interact with them mature too. So creating prompt templates, for example, so that, you may have an engineer who's worked out, this is a pretty good template, and now we can replicate getting the kind of information we want back. That's going to help, I think, companies, so there's just some hard engineering work, but then you get a template out of it that tends to be fairly useful in the long run.
So how long is it going to be until prompt ops is a thing? Because that's the natural evolution of this, right? We're doing prompt engineering now. In 3 years' time, it's going to be like prompt ops, where there's this meta process on top, or not. Adam?
I think it's a thing now. If you look realistically,
okay.
I think it's happening. It may not be a job description yet. I don't know if you guys are seeing that, but I'm.
So one of the things about LLMs that it's important to remember is that they are only ever as good as their training data. And they don't have we don't see a lot of people evaluating the training data in deep ways. So it's whatever is on the internet becomes the thing that the LLMs know. And just being realistic, the quality of threat models on the internet is not very good. The good threat models that are out there tend to be internal, confidential information rather than public information. And so I think that part of the engineering process, and I'm going to go to chaining, I'm going to go to evaluation, I'm going to go to variation here, is asking really small questions. I've been doing a lot of experimentation, and if you ask an LLM what security problems can happen, you get very, very generic answers. If you tell an LLM, I am deploying this using Terraform on AWS, what should I do about the security problems? You get some very specific answers. And so that leads me away from the LLMs are going to get smarter to we're going to get way better at using them. And I think that some of that may happen in playbooks and human ops engineering, but a lot of it's going to happen with tools like LangChain, with tools like specific tuning for LLMs for specific purposes. And I think that's the place where we're going to see a lot more success over time.
Yeah, I completely agree. I think that we are going to see an explosion of specializations of large language model in really specific things. The other thing is, how can I avoid the bias, or how can I have an updated model? Well, you can use a RAG, which is, something like a long-term memory for your large language model, which is going to be like a must to have part of of the galaxy of the applications around the large language model if you want to have a really good thing, like for threat modeling or any specialization thing. So yeah, I mean, these two things are needed. It's like a specific trained model in that direction and a RAG or something similar to a RAG. There are other technologies, but at the end of the day, it's going to be like the long-term memory for the large language model.
So not everything can be solved purely with prompt engineering. You need the extra around the edges. There's 3 questions, so let's jump over to those. Is there a specific framework for prompt engineering separate from the frameworks, best practices and regulations for AI, GenAI, while those requirements would naturally impact the engineers who use regulated governed AI? So I think the question here is there are there specific frameworks that we should be looking out for that really, I guess, help those who are sort of regulated, that are sort of within the remit of those organizations?
So, I mean, I think that, frameworks around use, right, as the question noted. In general, what I've seen around prompt engineering specifically is more around these kind of prompt template patterns.
Yeah.
Like, pain, what's the problem? What are we, what do we want to do? What kind of information do I want back? Or something like RISE, what's the role? Pretend that you are, and you're a expert threat modeler, you're as good as Adam Shostack, and then give me instructions on how to do something. So I think that when you're looking specifically at the prompt engineering, you see a lot of these templates coming out, and then the overarching frameworks of security and use are related to all of the use of AI, including what you prompt it with.
I think that go on.
Go ahead.
Go on. Okay, so I think that there is talking about the framework. Okay, if I had to choose something like helping me, this is for the audience, and probably they are going to be worried about how can I create my first prompt. A framework that can be useful, something in Anthropic. There is a called prompt generator, and yeah, you can prompt a large language model that is going to create a prompt. It's like a meta prompt. It's kind of difficult thing, but you're explaining the whole thing in a very vague language, and it's creating a really good prompt for your large language model. That's something like, yeah, I would use for that thing. There is something similar for GPT-4, but it's not supported by OpenAI. There is multiple GPT-4s. That GPT-4, ChatGPT has something that is there called GPTs. Well, there are many GPTs about prompt generators. So yeah, just if they are, if the people is looking for something, I will start from that point.
I think the thing that we're going to evolve to is we need unit tests. We need systems integration tests. We need to be able to take these things. Right, Diana mentioned 2 mnemonics, RISE and PAIN, which help you build a prompt. Which of these is better is something that you ought to be able to run a unit test on. Paula is asking in the chat, which model or vendor are getting better results? That is way easier to answer if you have a set of prompts that you can throw at all of these tools and then have something evaluate them. And there's, like we've seen DevSecOps and SRE evolve to code that runs your actual product. I think we're going to see prompt engineering evolve to, we need code that tests code that talks to LLMs.
Yeah, definitely. That's kind of what I was sort of jokingly hinting at when I said the sort of prompt ops. It's all the stuff you have to build around the prompt engineering to make that successful and operationalize it. It's inevitable, right? We saw the same thing with machine learning models themselves. ML ops, etc. A couple of more questions. Do we know anything yet about the difference in what OpenAI is saying they're going to provide, as in a new query engine to compete with Google? Any opinions on that, or should we leave that to the market to decide? Who knows? No one has any sort of sneaky insider connections to OpenAI. Probably shouldn't talk about it here anyway. Okay. If I type a query, I'm sorry. If I type a query prior to the completeness of the previous query, that input could affect the ongoing output of the first query. So I think that's just a sort of basic, like, how do you sequence and time your querying? Personally, I think you end up having to like stop it, right? Because it's just waiting for the API response to complete first. Is there's no real timing issues with any of this, right? It's all get the response, feedback, etc.
Yeah.
There's no degradation over time.
No.
It's just purely what's in the tokens, etc. Cool. And then we've got another question coming as well quite recently. Well, I'm guessing this is one more for IriusRisk, but we'll open up afterwards as well. So are you already using large language models to threat model architecture diagrams, analyze images or diagrams? What are your thoughts about that? So as people probably know, IriusRisk is currently implementing generative AI to automatically build the threat model for you. So we've got an MVP available that some of our customers are using now, and then we're going to be baking it into the product itself. And the whole idea there is you can give it, source code or documentation or user stories or SBOMs even, or meeting transcriptions. All of those things can be given, and it's one thing I've learned from watching Jose and his team working is there is a lot more going on than just prompt engineering. So the amount of engineering that has to go in to make something like this seemingly trivial problem actually work is pretty phenomenal. So yeah, that is something that we are actively working on, and obviously Jose can say a little bit more about that as well. But just before we pass over to Jose, Diana and Adam, are you actively using prompt engineering and large language models in day-to-day threat modeling, or is it sort of limited to playing around?
So I actually had an experience. I used an LLM to write some code for me, and then I asked the LLM to threat model that code. And this was prompted a little bit because I moved the files from one directory to another and didn't realize there was a cache file that had a JWT in it. And so my code broke, and I had to ask the LLM why my code broke. And then I said, what can the LLM tell me about the code that it's written? And so I have this real use case of I have some code that I don't really understand. What can the LLM do to threat model it? And so I fed the code back into it, and I said, what are the security implications of this code? What files does it depend on? It could not answer that question. And I got into some really, really leading questions. Like I shined a little spotlight on the thing that I knew was there, and I said things like, are there cache files that might contain security information? I don't know. And so my experience with trying to get the public models to do all of this convinced me that and gosh, this unintentionally is going to sound like a pitch for y'all, but it really convinced me that doing this without structure and tools isn't likely to work, and we really need to build the frameworks that enable the normal smart developers to get value out of the LLMs.
Thank you, Adam. Diana, any last thoughts on this?
Yeah, I would just underscore that not to sell one product or another product, but if we're going to these big LLMs expecting them to solve all the problems of the world, that's not really going to be the most effective. So starting to look for tools that are leveraging GenAI, leveraging LLM, but have been tuned and honed to solve specific problems. I mean, we did this, there was Watson at IBM, and I was in the IBM security team where we had to do Watson for cyber. It wasn't that we could just we had to train, and it was a years-long process to make sure Watson was ready for cyber. So these tools, these AI tools that are coming out that are purpose-built are probably going to be in the long run where you want to start doing some of these really purpose-fit kinds of tasks.
Right, well, that's pretty much all we have time for today. Thanks, everyone. Thanks to our panelists, Adam, Diana, and Jose. Check out the links that Claire's put on the chat for Adam and Diana's books. And thank you to everyone watching, and have a good rest of your day. Thank you all.
Thank you.